chapter 15.9, further definite integration. What you realize is that this part of the chapter is very similar to 15.7, if not mistaken, where we actually use a bit of adjustment and compensation, all right, as a technique to actually solve questions like this. It's very similar, and we'll go ahead and try these two examples to kind of reinforce the idea of how we do adjustment and compensation, okay? So, typically the question will ask you to differentiate some function using product rule or quotient rule, and then after that, they want you to integrate something very similar to what you have differentiated, but not exactly the same. So we have to kind of do some adjustment and compensation to make it to what we have actually differentiated, right? So that will allow us to integrate much easier. All right, so let's look at this example on the left side. So y is equals to 3x over the root of x squared plus 5. So we want to actually differentiate this, so we'll go ahead and use quotient rule, all right, to differentiate. So we have x squared plus 5 to the power of half times 3 minus, this would be 3x, and this would be x squared plus 5 to the power of minus half times minus half times 2x. All right, so quite a bit of things over there at the top. All right, and then we would square the denominator side, so we have x squared plus 5. Okay, now we can leave it here, but I don't think it's a wise idea because it doesn't really look like what we want to integrate later on. So I will choose to further simplify it. All right, so this would be 3 root of x squared plus 5. And then over on this side, you should have 3x squared over, let's see what we have. Okay, root of x squared plus 5. All right, and the whole thing is over x squared plus 5. All right, so a lot of work to be done at the numerator side. We're going to join them into a single fraction. So we'll go ahead and multiply root of x squared plus 5. So this will be x squared plus 5 minus 3x squared. All right, whole thing would be over root of x squared plus 5. And we can actually multiply the denominator with x squared plus 5. All right, so this will be just x squared plus 5. Okay, so we can go ahead and simplify that. We should be able to get us, let me see, 3x squared minus, okay, so 15 then, whatever left at the top. So this one we can convert it into root of x squared plus 5 to the power of 3, okay, which is, I think, kind of similar to what we want to find in the second part, which is to integrate 3 over root x squared plus 5 power 3. Okay, so we are done with the differentiation. So let's go ahead and integrate what they want us to integrate. So 0 to 2, 3 of root x squared plus 5 power 3. Okay, I'll use the red one to indicate what's going on. All right, so the difference between what we want to integrate and if I were to draw your attention to this is that one is 15, the other one is 3, right, for the numerator side. So what I'm going to do, I'm going to make it 15, so I will multiply this by 5. So this becomes 15, right? And when I multiply by 5 to the numerator, I have to multiply 1/5, all right? This is to adjust and compensate because the 5 don't actually exist before. So when I introduce times 5, I have to multiply by 1 over 5 so that it negates out. Now, this I can integrate, right? 15 over root of x squared plus 5 to the power 3 is essentially, if I integrate that, I should get 3 over root of x squared plus 5, okay? So I'll put 1 over 5, so I just copy and paste what was done before, so that would be just 3x over root of x squared plus 5, okay? And we are integrating from 0 to 2. Okay, so At this stage, now you just have to sub in the 2 and the 0 to work out the answer. So we can just sub in 2. So we have 6 over root of 2 would be root 9. 0, we can put it in quickly. So that would be, I think, just 0. Okay, so work this out. You should have 1 over 5 of 6 over 3. Okay, and let me see. So 2 over 5 will be your final answer. Okay, so again, we did adjustment and compensation. Just to recap, if we were to integrate 15 over root of x squared plus 5 to the power 3, that should get us back to this guy. All right, so that is why we introduce a times 5 to the 3 to make it 15, and we introduce a 1 over 5. So that whole process of adjustment and compensation, A and C. Okay, so if you're clear, you can try the next example yourself. You can pause the video right now, try it, and we'll see if the answer is the same. All right, okay. Okay, let's try the next example. So I hope you have tried it yourself. So if we want to do the first part, I think that's quite straightforward. We just want to differentiate that. So if y is equals to x cosine of 2x, so we'll use product rule to differentiate. So x minus sine 2x times 2 plus this will be cosine 2x. All right, so that is what we have done. You can clean this up further. All right, so this would be just cosine of 2x minus 2x sine 2x. Okay. Now, next part, we want to integrate 2x sine 2x dx from 0 to pi 6. Now, notice they are not very similar because there is a missing of cosine 2x. But no worries, what we will do is we'll just go ahead and integrate the previous example. So if we were to integrate cosine 2x minus 2x sine 2x dx, what we can get back is actually the original function of x cosine 2x, right? Basically, they are the same thing. Okay, so what we will do, we will split the integral part into two parts. So we'll say x cosine x 2x is just the same as the integration of cosine 2x dx minus the integral of 2x sine 2x dx. So what we want to do right now is we want to isolate this part because this is exactly what they want us to integrate. All right, and actually I forgot to put the limits, so I should put the limits down. Yeah, so 0 to pi 6, oops, 0 to pi 6, 0 to pi over 6, 0 to pi over 6. All right, so let's isolate 2x sine 2x, which is what we want. So we just bring things over. So to integrate from 0 to pi 6 of 2x sine 2x dx, this will be the same as if we integrate 0 to pi 6 of cosine 2x dx minus x cosine 2x. So I kind of just switch places with this guy. All right. Okay, so this is exactly what we want as per the question. So we go ahead and integrate cosine 2x dx from 0 to pi 6. That should get us sine 2x over 2 from 0 to pi 6. All right, and over on this side, x cosine x, we just leave it like that, x cosine 2x. All right, just leave it here for now. Okay, so what will happen is that before, remember, we are actually doing a definite integral. So basically, by working out this integration, this actually will be the same as we integrating this from 0 to pi 6. It would be the same answer. All right, so I'll just put it here, 0 to pi 6. So what it does is that we can actually put this back, 0 to pi 6. Oh, sorry, wrong position. 0 to pi 6. and 0 to pi 6. All right, so that will help us to actually evaluate the value. All right, so we sub pi 6 in, so sine pi over 3 times half, that would be half sine pi over 3. That will get us root 3, if I'm not mistaken. Root 3, right? Root 3 over 2. Okay, 0 we can sub in. I think will just be sine 0 will be 0, so it will be just minus 0. Over here on this side, we sub pi over 6, so pi over 3. So cosine of pi over 3 would be, what is cosine pi over 3? Cosine pi over 3 would be, I think the same thing, right? It would be, let me work out my calculator. What is cosine of pi over 3? That would be 0.5. So this would be pi 6 times 0.5 minus 0. Yep, so just leave it like that. Okay, so essentially what we have here is root 3 over 4 minus, over on this side, should be pi over 12. Okay, so we can leave it like that, or you can work it out in your calculator to get some decimal answer in three significant figures, or you can join them into a single fraction. So this will be 3 root 3 minus pi over 12. All right. Okay, so I hope it's clear on how to solve these two questions on further definite integral. If you have any question, just drop me an email and I'll be more than glad to answer them. All right, I'll see you next video.